So here we're asked to perform the integral, again with respect to x, of 5x plus the natural log of x. And we can see this time we've got bounds, so we should be able to conclude this one with an actual number, rather than just an equation with a plus c. Alright, so first step is to actually integrate. So fairly easy for this 5x, it's just going to be the regular integration rule with the polynomials, where you add 1 to the power and divide by the new power. So this is going to become 5, add 1 to the power, so it's already x to the 1, adding 1 would give it 2, and dividing by that new power, so divide by 2. This one's a little bit trickier, but if you have a table, it's not too hard. So the integral of natural log of x with respect to x, which you should be able to read off one of these integration tables that gives you the rules. So it's equal to x times the natural log of x minus x and plus c, since this rule is given as an indefinite integral. Okay, so utilizing this rule, we've got straight the integration of this thing straight away, so just copying this out. So x log x minus x, and this time we're not taking the plus c because we have bounds on our integration. So we're looking at from 1 to 2, which I'll carry over. So now it's just a case of actually substituting in our bounds. So we always start with the bigger one first, and popping it in for x everywhere you see it. So we're going to get 5 times 2 squared on 2, 2 times the natural log of 2 minus 2. And then we take away what happens when we substitute the second bound in, or the smaller bound. So putting in 1 every time we see x this time. Alright, so that's our numbers all substituted in. Now it's just a case of making this a bit nicer in terms of the final number. So we've got 5 times 2 squared, so that's 5 times 4, divided by 2, which is going to give us 20 divided by 2, which is 10. We've then got 2 times the natural log of 2, not much I can do with that yet. And then we've got minus 2. This one we've got 5 times 1 squared, so that's just going to leave us with 5, divided by 2. So that's 5 on 2, let's write that as 2.5. Then we've got the natural log of 1 minus 1. So keeping on going, we've got 10 minus 2, which is 8. Now I'm going to be tricky and put this back inside the log. So we're going to get the log. Remember, if you put this back in, it's going to go back to a power. So we're going to get 2 squared. Oop, I already put the 2 with the 10. Then we've got minus, I'll keep that there for now. So what, 2.5 minus 1, so that's 1.5 times the natural log of 1. Alright, keeping on going, let's keep this. So this expands to 4. Got minus 1.5 minus the natural log of 1. 8 minus 1.5, that's going to leave us with 6.5. And we can rewrite this using our log rules. So remember, let me use a different color, sorry. The natural log of A minus the natural log of B is equal to the log of A on B. Okay, so if we use this rule, we can rewrite our 4 and 1 inside one log. So we're going to get plus the natural log of 4 divided by 1. I think that's pretty much as good as we can go. In terms of our final answer, it's going to have to be 6.5 plus the natural log of 4. And of course, if you had a calculator with you, you could type this in and get some decimal representation of it. But I think that will do for us. So that's the answer and the conclusion of this video.